All right, today we're going to start lesson 22. It's on sum and difference identities. It'll take us today and tomorrow to cover all of the sum and difference identities. Today we're going to talk about sine and cosine, and tomorrow we'll tackle tangent. Today we're going to talk about how to find the cosine of an angle. If we think about that angle as the sum of two angles that we've already studied from the unit circle. So while I don't know what the cosine of 105 is, I do know the cosine of 60, I do know the cosine of 45, and I'm wondering, would the cosine of 105 just be the cosine of 60 plus the cosine of 45? And I really don't think that's going to work because I know two things. This angle is in the second quadrant, and it would have a negative answer for its cosine. These two angles both are in first quadrant, and they would have positive answers. So I'm just going to show you on the calculator that this doesn't work. Like the cosine of 60 plus the cosine of 45 would be 1.207, so forth. And we just said that that would be what we should get a positive number if we added those two. And then if I did the cosine of 105, it's a negative number. So while I told you that we're going to be talking about the sum and difference identities, they don't work straightforward like we think they should. The cosine of 105 is not like adding the cosine of 60 plus the cosine of 45. So we need to talk about these. Now they're in your book on page 468 through 467, but the reason I don't like to look at your book is because they do them as sum and difference at one time. The sum is the difference is the sum. So it gets kind of confusing. So I'm writing them here so you can see them. If I want to find the cosine of an angle that's made up of two angles that I add together, I'm going to take the cosine of the first angle and multiply it by the cosine of the second angle. While this is saying add, my rule has a subtraction sign in it. And then the second part of this would be the sine of the first angle times the sine of the second angle. Now the sum and difference differ only by these operations. If I'm doing the sum, my operation in the formula is a minus sign. If I'm doing the difference, my operation is a plus sign. So it's very important to understand, even while I'm doing a sum, I actually subtract these two products. When I'm doing the difference, I'm actually going to add those. Cosine of the first times cosine of the second minus sine of the first, sine of the second. Now that might be confusing to you because what in the world are V and U? So we want to look at an example here. And I'm asking you to find the cosine of 165 degrees using the sum identity. So the first thing I have to do is think about 165 in terms of two angles that I know from the unit circle. I know the cosine of 120, and I know the sine of 120, and I know the sine and the cosine of 45. So I'm going to think about 165 as 120 plus 45. Now that is not the only combinations that would work, so I don't want you to think that. But those are just two that I thought of. All right, so I'm going to go back up here and look at my rule. That's going to be, I'm trying to find the cosine, and I'm thinking of 165 now as 120 plus 45. So I go up there, and you have to understand that this is my U angle, this is my V angle. So the cosine of the first one times the cosine of the second angle minus the sine of the first angle, cosine of the second angle. Now, y'all, I know those values. The cosine of 120 is a negative 1/2. The cosine of 45 is the square root of 2 over 2 minus the sine of 120 is a positive square root of 3 over 2. The sine of 45 is the square root of 2 over 2. I need to do some multiplying here. Negative 1 times the square root of 2 is a negative square root of 2. 2 times 2 is 4. Again, 2 times 2 is 4, the denominator. There's that minus sign. Square root of 3 times square root of 2 is the square root of 6. And then I could just simplify that by putting it in one numerator. So square root of 2 minus square root of 6, all of that is over a 4. Now I want to do a second problem that's talking about the difference. Now there are different combinations that you could use for 15 degrees, but I thought of it as 45 minus 30. You could have done 60 minus 45. There are different combinations, but I guess I just went for the simplest one. So I'm thinking about 45 as being my U angle, 30 as being my V angle. So I'm doing the cosine of 45 minus 30. Cosine of the first angle times cosine of the second angle. Sine of the first angle times sine of the second angle. But here's the tricky part. Since that's minus, that operation becomes plus between the two products. The cosine of 45 is the square root of 2 over 2. The cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2. And sine of 30 is a half. That's the square root of 6 over 4 plus the square root of 2 over 4. And you can show their sum. Now these have the same numbers, but they are not the same really, because that's a negative and a minus and a plus and a positive. So whatever this value is, it is a positive number, and we think about the cosine of 15 degrees better be a positive number. Just like up here, 165 is in the second quadrant, its cosine should be negative. So I'm getting a negative numerator over a positive denominator, which would be a negative number. Now I'm taking it up a notch, and I'm talking about an angle as it's measured in radians. So I need to think about 5 pi over 12 as adding 2 angles that I'm familiar with. And you're going to say, I don't know anything, I don't know any pi over 12s, and you don't. But you can take that pi, that 5 pi, and break it into 2 parts. And I was thinking about 1 pi over 12 and 4 pi over 12. Well, I don't know any 12s, so that's not going to work. So break 5 pi over 12 into some other, let's say like 2 pi over 12, and what would that leave? 3 pi over 12, would that work? 2 pi and 3 pi. So I know that 2 over 12 would reduce to pi over 6, I know that one, and 3 over 12 would reduce to pi over 4, so I know those. So I'm going to think about, sorry guys, I'm going to think about 5 pi over 12 as 2 pi over 12, 3 pi over 12, and those will simplify into what I said, pi over 6 and pi over 4. Now go back and think about it. We're trying to do the cosine of these two added together, which are 5 pi over 12. Cosine of the first one times cosine of the second. Since it's plus, I'm going to do minus. Sine of the first one, sine of the second one. I'm going to multiply these out. Square root of 6 over 4 minus square root of 2 over 4. And I just kind of went ahead and did all that in one step, different than I had done up above. But this is still, even though I see those same numbers showing up, these are still different because this is square root of 6 minus, while that one was plus. Now I'm going to give you a break to kind of soak all this in, and then we're going to come back and talk about the rules for sine.